The other explanation for why we should not have interpreted this is that x equals 0 is outside the scope of the data. Remember, we have data, we have information for the used Toyota Corollas between 1 and 13 years old. Between those 2 points, that's where we can make interpretations and use regression. Beyond those two endpoints, our best fit line may not make sense. So 0, that's outside the scope, that's less than 1. So because of that, we should not make any interpretations. What about the slope? So we found that the slope was negative 959 and 5 cents. Yeah. Almost a negative $1,000. So how do we interpret the slope? So what this is telling us is how the advertised price changes as the age changes. So as we run along the age axis, how is the response axis rising or falling? So the interpretation would look something like this. It doesn't have to be exactly like this, but you'll get the gist. So as the age of a used Toyota Corolla increases by 1 year, or for every year older that a used Toyota Corolla is, this is associated with a decrease, because the slope is negative, in the advertised price of $959.05 on average. So as the age goes up by 1, as we run as we run 1 year older, this is associated with, doesn't cause, we don't know that, it's related to a decrease in the advertised price of the $959 on average. So on average, every year, these used Toyota Corollas should be $1,000 cheaper, roughly. Okay, that's what the slope is telling us. What's the value of R, the correlation coefficient? And then what does it tell us about this association? You can compute that on its own, but that's also present in this output. So they tell you, here's R, here's your correlation coefficient, negative 0.972, we'll call it. Okay. So what does this tell us? In other words, how would we interpret this correlation coefficient? So this tells us that there is a strong negative linear association between age and advertised price of used Toyota Corollas. It's close to negative 1, so that means it's strong. Negative tells us there's a decreasing association, and we're talking about linear relationships. Okay, so we interpret that just like before. What do the correlation coefficient and the slope have in common? What do you notice? Well, what's in common is they will always have the same sign. They both tell you the direction of your association. So here the slope was negative 959, and the correlation was negative 0.972. Okay. So there's one more thing to interpret. So one more diagnostic or statistic thing from the output. And it requires just a little bit of explanation before we interpret it. So if we look at the output, we have the dependent variable. Dependent variable is another way of saying the response. Independent variable, that's another way of saying explanatory. We have our best fit line. We have a sample size. We have the correlation coefficient. So there are two things left. This estimate of error standard deviation, we're not going to talk about it. There is a meaning to it. We don't really care. So what we will discuss is this thing called R squared, and it's 0.944. Okay, so its name is what it is. If you take the correlation coefficient and square it, you will get R squared of 0.944. So if you do negative 0.971 times negative 0.971, you'll get that. Okay, so what does it mean? What it's helping us to measure is how useful is it to have the extra information from age. Okay. So what I mean by that is, for a moment, let's imagine that we know nothing about the ages. All that we have are the prices. Okay? So we have all 15 of these prices. So we look at its summary. So at the bottom of the table on page 2, here's everything we know about the price. So our question is, say you want to buy, I don't know, maybe that 2-year-old used Toyota Corolla. What do you expect its price to be? On average, what do you think you would pay for that used Toyota Corolla if all you have is information about prices? Well, your best guess is going to be the average. So you would say, I expect to pay about $8,400 for any used Toyota Corolla. Well, that may be okay, but it's probably not going to be very accurate. So we know that there's quite a bit of variability across the prices. They range from $14,000 to $3,000. And we're saying, okay, we're just buying any used Toyota Corolla. What would we expect to pay? Well, with that limited amount of information, our best guess is the average. So now what we want to know is, can we improve that estimation? Can we do better than just the average price? And that's where R squared comes in. So what R squared is measuring for you is, what if you had an additional variable? What if you knew something about the age of the car? How much better will your predictions be? How much better will your estimations of those used Toyota Corolla prices be if you know something about its age? And because there's such a strong relationship between the two, what we now see is that, okay, if we turn this sideways and you imagine taking all of these points and just squishing them down onto the y-axis, this is kind of a dot plot of all of the different prices. They vary quite a bit. And when you add an age, you see that, well, these prices change as the age changes. So now what you can say is, well, what would I expect to pay for that 2-year-old used Toyota Corolla? So now, rather than saying, oh, $8,400, since that was the mean, that's not really a good price if you're in this 2-year-old car range. What you would expect to pay is somewhere up here. So you can improve your estimations using age. How much better are your predictions? That's what R squared tells you. So that's what this little definition is all about. So R squared, sometimes called the coefficient of determination, measures how much better our predictions will be for the response variable using the regression line. In other words, using what we know about x and y and their relationship, as opposed to only using y bar. So that's just the average price of all the cars. So in this case, our R squared was 0.944. Okay, so what this is basically telling us is that if we know something about the car's age, our predictions for its advertised price will be 94% better than just using the overall average price. So the interpretation is kind of odd, but it means the same thing. So it looks something like this. Approximately 94.4%, so we're just converting R squared to a percent, of the variability in advertised price is explained by the variability in age. Okay, so that means the same thing. Why do we have all of these different prices? Why do they range from 3,000 to 14,000? Well, it's because the ages also vary. They vary from 1 to 13, and there's a strong relationship there. So all of those different ages, that's explaining mostly 94% of why there are different prices. So what you can think about is, okay, well, if 94% of the variability in price, that range from 3,000 to 14,000, is attributed to age, what else is explaining that variability? What's the other 5.6%? What's the other minor reason or reasons there are different prices? And these are things that we talked about on Thursday. What else could impact the price of a car? Well, correlated with age is going to be the mileage. More miles, less value. You can think of things like, has it ever been in an accident? That's also going to play a part. Now, these data are like a textbook data set, not overly realistic. So I doubt that age has this much of an impact in price. It's probably substantial, but it's certainly a combination of things that really explain differences in price. Okay, so that other remaining variability, that's due to other explanatory variables. Okay, so let's now think back to that 2-year-old used Toyota Corolla that we might want. What's the predicted average cost of that 2-year-old car? Should we purchase one that's been advertised for $13,300? And then we'll compute the residual for that data point. So if you want to make a prediction, you're just using the best fit line. So what this is saying is that x is 2, the age is 2. So we're going to plug this into the y hat equals 14,285.95 minus 959.05 times x. So all that we're doing is we're plugging in a 2 for the x. Okay, so I have to get my calculator. Oh, let's see. So we have 959.05 times 2 And then we want 285.95 minus 1918.1. So our predicted price for a 2-year-old car is a little over $12,000. So y hat, the average advertised price, will be $12,367.85. So should you purchase a car, a 2-year-old used Toyota Corolla advertised for $13,300? Maybe, maybe not. So it's certainly priced above what we would expect to pay by about $1,000. But we have to remember the bigger picture. This is only accounting for age. So that's also another 2-year-old car. So then why is it priced so high? Maybe it has low miles. Maybe that justifies the price. So if that